The observer pattern declares a one-to-many relationship between objects, where multiple dependent objects are automatically notified when the state of an object changes. The observer pattern is one of the 23 Ganov patterns divided into three categories: creational, structural, and behavioral. This pattern falls under the behavioral category. The observer pattern is also called publisher-subscriber pattern, but they are not the same. The observer pattern is commonly implemented synchronously. On the other hand, the publisher-subscriber pattern, also called pub-sub messaging, handles asynchronous message queue flows. This design pattern has multiple applications: newsletters and magazines, commercial websites to notify customers about new product releases, weather systems and push-based notifications, social media platforms by following people, channels, communities to be notified about new posts, service communication through microservices architecture, Angular observables. Furthermore, the observer pattern is the foundation of the model view controller pattern, in which a view is updated automatically whenever the model's state changes. It's time for a demo. Welcome everyone. Today we will learn how to implement the observer pattern in C# with asynchronous event notifications. So open Visual Studio Code and add a new console add project called observer pattern. Add a new class which contains all the observer pattern implementation. The first class that I want to add is the data that we will send to the observers or consumers. In this demo, we'll send a promo model that will contain a promo code to buy a product, applying a promo discount. So add a public class called promo discount. This class will contain three properties: the product, the code, and the discount percentage. And now we're ready to use all the observer pattern elements. The first one is the subject, or also called observable. Add a new abstract class called promo discount notifier. And let me add a comment referencing the subject, or also called observable. This class maintains a list of observers and sends notifications when its state changes. So add a property that is a list of a promo discount listener, that is the interface that will represent the observer, and the name observers. Initialize the list and add the interface. This promo discount listener is the second element of the observer pattern, that is the observer, also called consumer. And this element is interested in state changes of the subject. So observers implement an update method to add a task, because we will handle asynchronous event notifications. And this task is the update method that will receive the promo discount model. So far so good. This subject or observable also register and notify consumers. So add three methods. The first one to add observers. Add observer that receives the observer and add it to the list. The second method is to remove an observer, and the final method is to actually notify all the observers when the subject state changes. It will be an asynchronous operation. Notify and receives the promo discount object, and I will use when all method that will execute multiple tasks in parallel, but the final will return the result when all the tasks are completed. So here, call the observers list and select the tasks that are the update method, passing the promo discount object. Great. The next element from the observer pattern is the concrete observer. For this demo, we'll use two observers to print the message via console. The first observer or consumer that I want to add is the website consumer that implements the iPromo discount listener. This concrete observer is the specific implementation of the observer. To simulate asynchronous events, I will add a delay from this update method of 3 seconds and then print a message to the website consumer using the promo discount parameters. So add interpolation and first of all print the name of the website consumer. You have a promo code, promo discount that code with a promo discount that discount percentage for the product, promo discount that product. This is the message that we will print to this website consumer about the notification from the subject. Let me add another concrete observer. The second observer will be for newsletter consumers with a delay of just 1 second. It's almost the same update logic from this consumer for demo purposes, but here the name of the consumer is newsletter consumer. And the final element of the observer pattern is the concrete subject. This concrete subject is the specific implementation of the subject. It will notify observers when its state changes. So a class called promo discount service that inherits from the promo discount notifier add an asynchronous method to send the promo discount, send promo notification by receiving the promo discount and calling the notified method. Great, it's time to test the implementation from this observer pattern. Go to the program.cs file, remove this code and add the concrete subject. Create a new instance of the promo discount service. Add 2 instances from each consumer. The first one is the website consumer. The second consumer is the newsletter. Add the observers to the subject, website consumer and newsletter consumer. Now we're able to send notifications to the consumers. To that, use the promo discount service object and invoke the notify method, passing the promo discount object, define a code, discount percentage, and the product. This is an asynchronous method, so add the await keyword. But before testing this implementation, I will remove an observer at runtime to test the flexibility of this pattern, so-called promo discount service that remove observer and remove the website consumer. Console that write line, website consumer has been removed and notify all the subscribers, all the observers, consumers on the promo discount subject, calling the notified method again. Okay, let me add a console that read key to prevent closing the console. Execute project, waiting, newsletter consumer notification arrived, and then the website consumer. This newsletter consumer, as you remembered, has a 1 second delay. The website consumer has 3 seconds, so it arrived at the second position, and at runtime I removed the website consumer from the subject. In this case we just have 1 consumer, that is the newsletter consumer. What are the benefits of the observer pattern? Flexibility. Observers react independently to updates from the subject, and the subject and observer are loosely coupled. Open-closed principle. Observers can be added or removed at any time without affecting the pattern implementation. Reusability. Observers can subscribe to multiple subjects if they adhere to the same update interface. And the drawbacks are the updates. The order in which observers are updated is not always predictable. This can be difficult to handle in a system when order execution is critical. Performance overhead. This pattern can introduce complexity, particularly when there are many observers to work with. It can be time-consuming to notify all subscribers. Execution flow. When the pattern is not executed properly, it can lead to unexpected notifications throughout the system. If you want to learn more, don't forget to subscribe. May the code be with you.